Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing graded classwork about refraction of light for extended candidates. Let's start by question 1. Okay, question 1 is asking you about the speed of light wave in water, the speed of light wave in air is given, and the refractive index is given. Okay, you can apply the equation that refractive index is equal to the ratio between speed of light in air and speed of light in the medium. If you substitute, we can rearrange first, then substitute. So V is unknown is equal to C over N. So 3 times 10 to the power of 8 divided by 1.33. So the answer is 2.3 times 10 to the power of 8 meter per second. Don't forget to write down the correct unit, and units should be consistent. The second part is very important because it's asking you to draw. We have I, double I, triple I. We have 3 parts of this question. We have parallel wavefronts of a light wave in air incident on a boundary. You have the other medium is transparent plastic here. Number 1, draw positions of 4 refracted wavefronts in plastic. Okay, I will explain the steps slowly, step by step. Number 1, I would like you to, I will draw it to show you how to draw at every single point intersecting the boundary here. Okay, so you can make sure your answer is correct. Okay, so first of all, I will draw normal lines. I will draw normal lines at the boundary at these points. Okay, before we draw in details and explain, you are expecting what you will get when you draw. You have here the more dense medium. The more dense medium is plastic, because we said earlier that air is less dense. So here we have less dense, and we have here denser medium. Okay, what do you know about air and the speed of light in air? Speed of light in air is the maximum speed of light in all media. So what happens when it enters the transparent glass? Speed decreased and wavelength becomes shorter. Okay, so the wavefronts you will draw now in the transparent plastic, the distance or the spaces between the wavefronts will be less than the wavefronts you have in your diagram in air. So this is number 1. Before we start drawing, you are explaining to yourself what are you doing. Number 2, you have to extend the direction of light wave. Okay, direction of light wave is usually perpendicular to wavefront. So it's perpendicular to wavefront. So if I draw the direction of light wave at the first point, okay, so it should be parallel to the one you have in your diagram. So if I draw this, make sure it's perpendicular to wavefront. So this is the first one, okay? And you can draw also the second one parallel to the first one. Make sure it's perpendicular to wavefront, okay? At the third point of intersection, it's also here, okay? And at this point, all this red rays, they are the direction of light wave, okay? Okay, let's draw the wavefronts in different color. No, let's first draw the refracted light ray. So here, when it enters from less dense to denser, it will refract towards the normal. So you will draw here towards the normal. The ray will be refracted towards the normal. So I am here drawing the direction towards the normal. Okay, towards the normal. So this will be the direction how the light wave, when it enters the plastic transparent, how it will behave, okay? So I should draw now wave fronts at these points. They should be parallel to each other, equally spaced, and they should be perpendicular to the new direction of light waves, okay? So you can draw it like this. Make sure it's perpendicular, okay? So wavefronts, I will show you now how the last one. Okay, so the direction is perpendicular to wavefronts. We are checking, just checking. Okay, so now you find wavelength is shorter. The distance between here, the spaces between wavefronts, the new wavefronts in the transparent plastic, they are shorter. Because according to the wave equation, in refraction, frequency is constant. So as the speed of light in air, when it enters transparent plastic, the speed decreased. So also the wavelength is directly proportional to the speed at constant f. So accordingly, what happens to the wavelength? It will be shorter. So now you can make sure that your drawing is correct. Okay, back to our question. The positions of the 4 refracted wavefronts in plastic. So this is done. Draw an arrow to show the direction of travel of the refracted wave. We did it already during our steps to draw, because I am explaining in details. Label the angle of refraction of the light wave. Okay, so carefully, because we have here many straight lines. So at any one, so this is clear, you can mark here, label the angle of refraction R. So this is the angle of refraction, which is between the normal and the refracted ray. Okay, or refracted light wave. So this is refracted light wave. Is it clear, guys? So far so good. So we are done with this one also.
Subscribe for more videos. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics Blender.